Good evening, everyone. This is Team TechScrum. My name is Mark. I'm the team lead of the DevOps team. And these are our team members. My team and I will walk you through a comprehensive overview to showcase the key elements and objects of the project. And here are the topics we will cover for today. We will begin by discussing what is TechScrum, followed by project architecture, CI/CD, front-end, back-end, security, and monitoring. We will also share our expectation for the future. At the end, we will have some spare time for question and answer. And now let's dive in the first section. What is TechScrum? TechScrum is a unique and user-friendly product management software which tolerates for the agile world. It is designed to help the company to avoid costly delays and maintain control over their budget. The ability design UI ensure seamless navigate and use. Today, however, our focus is on the intersection of TechScrum and DevOps. So we will explore how TechScrum's continuous integration and deployment integrated within the project, ensuring a seamless and productive deployment lifecycle. So this is our architecture. We create a whole AWS infrastructure components by using Terraform. And as you can see, we have got a few different sections, include CI/CD pipeline, front-end, back-end, security, and monitoring. It might look a bit confusing now, but our team members will introduce them more in detail in the coming section. And now I'm going to walk you through the Jenkins CI/CD overview. So we have set up the pipelines for both UAT and production environment. They are multi-cloud environment, which include AWS and Azure Cloud Platform. The Jenkins servers are configured by Terraform and Ansible. The majority of pipelines are running on AWS EC2, where Jenkins master and slave are. And as you can see, we also set up another pipeline on Azure for failover function. The front-end pipeline is responsible for building and deploying our front-end application. It checks out the front-end code, install dependency, builds the application, and deploy the artifacts to S3 bucket. Similar to front-end, the back-end pipeline checks out back-end code, install dependency, and we have also add a sneak scan for code security and builds the Docker image, push the image to ECR repository, and deploys to ECS cluster Fargate. And we also got the ISE management pipeline. This pipeline is for managing our infrastructure as code. So whenever we make changes to our IAC, this pipeline validates, plans, and apply those changes using Terraform. We have also integrated TFSec into this pipeline to enhance security scan for potential security issues. Lastly, there is the Jenkins infrastructure pipeline. It's responsible for managing the infrastructure of our Jenkins server that applies changes to Terraform configuration. So with these pipeline implementations, we can ensure our multi-cloud support, security, and resiliency, thereby streamline the CI/CD process. So these are all about our CI/CD part. Next, we will have Melissa to bring us walk through the front-end section.
Sure, thanks, Mark. Front-end hosting on AWS shows a static website to users. Terraform as IAC is employed to create cloud resources, while S3 is automatically uploaded through the pipeline to serve web server. Type out of domain, TechScrum gr11.com triggers WAF to identify malicious requests by implementing geo restrictions. It also brings captcha puzzle challenges to enhance security. After WAF check, Route 53 will route traffic to CloudFront. CloudFront, our CDN globally distributes content by using edge locations in our case. It also enhances security by creating S3 bucket policy, which only allow user accessing S3 content through CloudFront. An ACM certificate encrypts data in transit for CloudFront to secure our domain. Of course, DNS validation verifies ownership of the domain. And now Didi will talk an even more robust AWS infrastructure. Over to Didi.
Sure, thank you, Melissa. So yeah, next page, please. Yeah, actually, I just pick up one part for the S3 bucket backup and the failover triggered by the Lambda. So Yeah, I was showing on the PowerPoint, and there's 3 package, primary and backup package, in the different region. Access log hosted in the same region as the primary. Lambda function written by Python and trigger to the new and the delete object. Sync between primary and the backup packet. The most important point, there are 2 trigger. So one is for the create event, another one is a delete event. So cannot only single one trigger because they are to the different event types. Next page. So this is for other streams. So need to enable event bridge and event notification on the primary bucket. Run the same lambda function create in early. Event type also need to separate by the object create and remove. Event bridge need to create a rule attached to the primary bucket on the create delete object. Target on the SNS topic, which is a send email to subscriber email. Next page. Yeah, here just to share my some learning experience and working strategy reflection. So the first one is a TOEFL learning, and I manually create AWS server on a console. Then made a TOEFL configuration file, compare the console steps, and also use other people's example and to learning from the official TOEFL document. In the next, need to improve the structure code and the module and reusable. Regard to the GitLab, I mainly used it for version control and provide the source repo to the pipeline. In the next level, more deeply work with a team member. For example, branch merge and Confluent. Try to practice and understand the company project gives the workflow. The next one is regard to the jacking pipeline. So in this part, I have 2 pipeline for my own part. Deploy AWS configuration from the TOEFL file and npm build package and upload to S3 package for the 3 package. Can get more practice in the next level, especially sort of a different environment and a more complex implementation. From the general side, I learn from have understand the AWS-based full stack web, RN project architecture, briefly understand the workflow of the DevOps concept. In next level, want to invoice more parts such as a backend structure, Python coding, various code architecture. So next, I will be passed to Lawrence for the backend.
Okay, thank you, Lidi. Hello, everyone. I'm Lawrence. I'm going to present the deployment of our backend ECS services. Firstly, all our AWS resources in our backend are also deployed by the Jenkins Terraform pipeline. This pipeline is manually triggered, and the Terraform state file will be stored in S3 bucket for further debugging. And from the right hand of this slide, we can see the backend CI/CD pipeline. When our Jenkins server receives push hook from GitHub, the backend CI/CD pipeline will run automatically, and the new Docker image will be built and then pushed to AWS ECR. Eventually, ECS will pull the latest Docker image from ECR, and the ECS services will be updated. As for the entire ECS backend architecture, actually we operate in production and dev environments. And in order to control costs, we simplified the dev environments by putting the Fargate services into public subnets, which is a bit different from this production environment. Okay, let's focus on this architecture in production environment. As shown in the central diagram, our application backend is deployed on ECS Fargate services. And firstly, I'd like to explain how traffic travels within our backend system in short. When our backend receives requests, the traffic first passes through the load balancer via the internet gateway, and the load balancer distributes the traffic to target services of two availability zones. When the backend in the container returns data, the traffic will be directed to the net gateway according to the route table, and eventually pass through the internet gateway. Apart from the traffic, we can see that two availability zones are configured in the backend. This ensures that even if one zone is down and our website is still accessible. And our auto-scaling policy dynamically increase or decrease the number of tasks, which is very useful to ensure that our applications have sufficient computer resource and minimizing resource waste. Okay, that's pretty much about backend ECS. Now I will hand it over to Leo. He will introduce the security and the Kubernetes parts of our project.
Thank you, Lawrence. Hello, this is Leo. When Route 53 detects unhealthy in the backend ECS, it triggers Lambda function, which in turn triggers the job in Jenkins to deploy Elastic Kubernetes service. Using EKS for failover deployment keeps applications running smoothly. We use ALB ingress to manage the traffic. Also, we set up the horizontal pod autoscaler and the cluster autoscaler, ensure high availability and performance while optimizing resources. We also set up a bastion host to access resources securely. Using persist volume claims and AWS EBS volume, ensure data persistence. In the top right part, connect AWS IAM rules with EKS service account by OIDC. This allows us fine-grained control over permissions. Also, we integrate Helm to install Prometheus and Grafana easily. In the bottom right part, an EFK stack was deployed using manifest YAML as the login tools, where Elasticsearch is the stateful set, Fluentend is the demo set, and Kibana is the deployment. Next page. This part is about security compliance. In our project, we ensure code security using third-party tools in continuous integration paths. For instance, we use to scan and fix vulnerabilities of the code. Use TFSec to scan our Terraform code, and use Git leak to detect and prevent the exposure of credentials. Next page. We improve security through various services in AWS. For example, add Wolf before CloudFront and integrate AWS Security Hub to send a notification when find the critical alert. AWS CloudTrail is used for security analysis and auditing. Through AWS CloudTrail, we record API call events to trigger Lambda that automatically tags containers in ECS and EKS. Next page. This part is about the authorization and authentication. In EKS, we attach an IAM rule in Kubernetes pod, while integration between AWS IAM and the Kubernetes service account. In ECS, we follow the policy of least privileged access. Also, we use AWS organization to centrally manage and control multiple accounts, and enhancing overall security through service control policies. We build master, dev, and production organization unit to manage multiple accounts. Thank you. And let's hand over to Shiqi.
Okay, let me introduce the overall architecture of the monitoring and logging, which is mainly divided into three parts: metrics, logs, and alarm. Next page. The first is the collection of the metrics. Determine the extract metrics by writing the config YAML file of CloudWatch exporter. Extract the metrics into the Prometheus and finally display them through the Google funnel. Next page. Then there is the log part, which extracts logs from the CloudWatch logs to OpenSearch cluster through Lambda function, and finally display them through a dashboard. There are two alarm parts. One is to send email alerts through SNS, and the other is to trigger the corresponding policies to operate through fixed thresholds, such as expansion and contraction, which will be explained in detail later. Next page. Here are some of the main metrics we focus on the front end and back end. For Route 53, we did a health check and monitored HTTP and HTTPS. For CloudFront, we paid more attention to errors starting with 4 and 5. As for the backend, ECS and EC2, we paid more attention to the CPU and the memory conditions and the network I/O. Application load balancer is also a very important part. We also set up the following metrics to monitor the specific of the application balancer, and also set up corresponding alarms. The following is which some of the metrics dashboards looks like. Next page. Okay, next page. Here's the Kubernetes in the graph funnel. Okay, next page. The last part is the alarm part, which is part of the alarm configuration. Most alarms will eventually be sent to the corresponding person in charge via SNS. There are also some such as CPU-related alarms and memory-related alarms. After reach the threshold, they will trigger a corresponding expansions and reducing policies to ensure responsible allocation of the system resource. Next page. So we also made some plans in phase 2, such as enhancing backup and disaster recovery, comprehensive load testing, and reduce operational costs, and integration of AI, such as using the anomaly detection. Next page. Okay, that's all. Thank you.
So this concludes our presentation for today. Please do not hesitate to ask any questions, and I would like to thank all the team members for their effort. Thanks for your listening.